So now a solution for 12-15. This is a slightly more complicated problem, especially using the k-tables because you got to look up a whole bunch of values on those really lovely k-tables in the appendix. So we want to find the bubble point pressure of the following mixture at 140 Fahrenheit using the k-tables. Here's our mixture, here's the compositions. So step one, type in all of these over in Excel, which I've already done. So Z values, these are the values from the problem. Here's our different components. The temperature is 140 Fahrenheit, and just so I can let everybody know, I went through and solved this problem using equation of states, and I got about 63 psi. It uses equation of state, so this is a pretty exact answer. So I already know that my answer is around here. You would not know that going in head first. I tried to solve this problem straight out of the box. It's no fun because you got to do a lot of guessing to try to get to the right values. So anyway, the way you would work this is by looking up values in the k-tables. You need to do you need to do two different values and hopefully bound the lower and upper pressure that where your bubble point would be at. So I just took 40 psi and 100 psi because I know it's in between them. So if we go to 40, we go over to the k-tables. If I come back here, by the way, this problem is just like the example problem. Which example problem is it? This example problem 12-16. So you're basically trying to find where this is equal to 1 exactly. Z times k, that's going to be it. So you got to guess. That's what they're showing you, is do a few guesses. So if I come back to the k-tables in the back, in the appendix, come on. I would go to propane. Come on. Get there. Now, there we go. I would come to the propane. Here it is, propane table. I just drew a line here for visualization purposes. So I would come to say wherever I think my bounds are. So 40 psi, and we know the temperature is, sorry about that. We know the temperature is about 140, which is somewhere around here. And our value would be about 8 something ish for our K. Actually, 6. It's not 8, that's 6. So about 6. I got 6.66, more or less 6.66, 6 to 7, somewhere in there would be the value. So I would enter that in for 40 psi, and then the 100 psi value, same story. I would come here and move over to the 100 psi line, which is nice because you can see where it changes color right here. That's where 100 is, in case you wondered how to read a log plot. And move this down to where it's around the 140 Fahrenheit line. Come over and measure. It looks like I'm at 2.5 or something like that. How about 2.6? Looks good enough to me. So you keep going through, do the same thing with the butane tables. Already did that. But you'd go to the butane tables, do the same thing. Find the value at 40, find the value at 100, type those in 40 and 100. Same thing for the next pentane table. Same thing for the hexane. And then we can add them up just like the same. This is greater than 1, greater than 1. That means that we have a two-phase mixture. We don't want a two-phase mixture. We want the bubble point, which would be where these values equal to 1. Actually, no, these values equal to 1. It has nothing to do with these. So we can calculate at the 40 psi. This would be a calculation of Z times K. And the sum of these we want to get to equal to 1. So Z times K, this would be Z times K of this value. Same story. We go through and add all these up. And then at the bottom, we want to do a summation of all these values, that should equal 1. And we can see it doesn't. The good news is this one's greater than 1, this one's less than 1. So our answer lies somewhere in between these two. So I basically just create a simple line plot. You create a line plot. Here's 40. Here's the values. This is this value for 40, this value for 100 psi. Plug those in, do a curve fit, and here's the equation. I would copy that equation and plug that in here. We can see on this plot that where the value would equal 1, where it crosses 1 right here, is roughly in here, so it's about 70 something. And so there's the equation. You can sit there and guess values, or you can use the goal seek to solve that too. If you want to see what goal seek looks like, if I type the wrong value, this is obviously not equal to 1. So if I go do goal seek, I want to set that value to equal 1 by changing this value. Go ahead and solve. There's a solution. It's about 76 psi. I bet he was shooting for 75 psi if I had to guess, knowing how McCain's life is. The equation of state model got us about 63 psi. These are extremely complex fluids. It's complicated. Getting within 10, 15, 20, 30% of each other on your answers, knowing how crappy those K tables are, you've done a magnificent solution. So it's somewhere between 60 and 80 is your answer. I'm guessing he was shooting for probably 75 because that McCain's feel good like that. But that's how you solve that one.